Good morning, good afternoon, or good evening, folks. I hope you're doing well today. We are back in Unit 7, which is all about motion. Now, we have already covered Lesson 7.1 and 7.2, so if you need to, just take a moment to go back and review those. Today, we're going to start on Lesson 7.3, which is all about acceleration. So, acceleration is a change in velocity. So let's take a minute to review what it means when we talk about an object's velocity. Velocity is speed with direction. So if you want to change your velocity, you can either change your speed by speeding up or slowing down, like if you're in a car hitting the accelerator or the gas pedal or the brake pedal, or you can change your direction by turning the steering wheel. So these are the three ways that you can change your velocity in a car. You can speed up, slow down, or change direction. And if you do any of those things, then you have experienced acceleration, because acceleration is simply a change in velocity over time. We'll get to that in just a moment. So the formula for change in velocity, or delta V, remember delta means change, is to take your final velocity minus your initial or original velocity. And a lot of times in physics, we will take a quantity like v for velocity, and we'll attach a little letter to it called a subscript, which is just like an adjective, a word that describes this quantity. So f for final velocity and I for initial velocity. So we're going to look at a situation here where we have two cars whose velocities are changing as they run down this stretch of road, and we're going to see if we can calculate the initial and final velocity and the velocity change. We'll start with a red car. So the red car starts out slowly, and it passes this marker at 5 meters per second, but then it speeds up and passes this marker at 18 meters per second. So its initial velocity was positive 5 meters per second. We're defining moving to the right as positive. And its final velocity was positive 18 meters per second. So its velocity change is positive 18 minus positive 5, or positive 13 meters per second. I include the positive sign to indicate that the velocity is increasing in the positive direction. Now let's look at a blue car. The blue car passes this marker at 18 meters per second, but slows down to 5 meters per second as it passes the second marker. So its initial velocity is positive 18, and its final velocity is positive 5. To find the change in velocity, or delta V, we take positive 5 minus positive 18. Since 18 is bigger than 5, this is going to wind up with a negative number. The blue car's velocity change is negative 13 meters per second. And it's negative because although the car is still moving in the positive direction, its velocity change is negative, which means it is slowing down. So an acceleration is the rate of change in velocity over time. In other words, how quickly your car is speeding up or slowing down or changing its direction. The abbreviation for acceleration is a lowercase a, so unlike momentum, this actually makes sense. And the SI unit for acceleration is meters per second, or meters per second squared. Now that's pretty weird, so let's take just a brief moment to talk about that. Meters per second. If you're accelerating at a rate of 1 meter per second, then that means that every second that goes by, your velocity is increasing by 1 meter per second. So maybe you start from a standstill, and then after 1 second, you're going at 1 meter per second. After 2 seconds, you're going at 2 meters per second, and so on. If your acceleration is 1 meter per second, then for every second, your velocity increases by 1 meter per second. So just want you to understand where that unit comes from. Acceleration is a vector, which means it does have a direction. Now the basic formula for acceleration is a is equal to delta v, or velocity change, divided by time. A is equal to delta v over t. So you know we're going to draw a triangle for acceleration. A is equal to delta v divided by t. If we wish to calculate the velocity change, that's acceleration times time. Delta v is equal to a times t. And if we wish to calculate the time that passes while an object is accelerating, t is equal to delta v divided by a. 3 formulas for the price of 1. Gotta love it. Now, remember we said that delta v is equal to vf minus vi, the final velocity minus the initial velocity. So we can change this formula a little bit. We can say if a is equal to delta v over t, then a is equal to vf minus vi over t. This is actually the more useful formula to use, so when we solve word problems with acceleration in just a minute, we'll probably be using this formula more frequently than we'll be using this formula. So here we have two speedometers, which might be found in two separate cars, and these speedometers measure speed in meters per second, which typically is miles per hour or kilometers per hour, but that's okay. We're going to watch both of these speedometers showing some acceleration, and then we'll talk about which one is showing the greater acceleration. This stopwatch will keep track of how much time has passed. So right off the bat, we can see that this speedometer's needle is going up way faster. So in a span of 5 seconds, the speedometer on the left went from 0, which was VI, to 40 meters per second, which was VF. So we say its velocity change was 40 minus 0, which is 40 meters per second, and it took 5 seconds. So 40 divided by 5 is an acceleration of 8 meters per second per second. For every second, this needle rose by 8 meters per second. On the right-hand side, it went from 0 to 60 meters per second. So that's 60 minus 0, which is a velocity change of 60 meters per second, divided by 5 seconds, or 12 meters per second squared. So just as we said earlier, it's very obvious that this car is experiencing a greater acceleration. They're both accelerating for 5 seconds, but this car puts on much more speed or increases its velocity by a much greater amount during that time. Now this time we're going to watch two separate cars accelerating, measure how long it takes for them to do that. Okay, both cars accelerated from 0 to 40 meters per second, but the car on the left took 5 seconds to do this, so its acceleration is 40 minus 0, which is 40, divided by 5, or 8 meters per second squared. The car on the right, it took 8 seconds to go from 0 to 40, so its acceleration is 40 minus 0 divided by 8, or 5 meters per second squared. So if you increase your acceleration, there's two ways you can look at it. Either you will get to a higher velocity in less time, or it would take you, you could get from a higher velocity in the same amount of time, or it would take you less time to get to the same velocity as another vehicle that has a smaller acceleration. So let's look at some word problems for acceleration. A motorcycle accelerates from rest to 20 meters per second in 5 seconds. What is the motorcycle's acceleration? Let's start by listing the information that's given. Now it says it accelerates from rest, and whenever we see the word rest, that always means 0 meters per second. So the motorcycle's initial velocity is 0 meters per second, its final velocity is 20 meters per second. In reality, I should be saying positive 20 meters per second because it is a vector, so I should be giving it a direction. So that's my bad for not including that detail. And the time is 5 seconds. What's unknown is the motorcycle's acceleration. So we will say the acceleration is equal to the delta v divided by the t, and remember delta v can be written as vf minus vi. It is very important that you put them in that order, vf first and then vi. And now we will substitute. vf is 20 meters per second. vi is 0 meters per second because the motorcycle started from rest, and the time is 5 seconds. Solving, 20 minus 0 is positive 20 divided by 5. 20 divided by 5 is positive 4 meters per second, or positive 4 meters per second squared. The motorcycle's velocity increases by 4 meters per second for every second that is accelerating. Does this answer make sense? Yes, it does. If you accelerate at 4 meters per second every second, then after 5 seconds, you will have increased your velocity by 20 meters per second. And the units check out, so this answer looks pretty good. A pickup truck slows from 30 meters per second to 14 meters per second in 8 seconds. What is the truck's acceleration during this time? So we'll start by listing the information that we know. The truck's initial velocity is 30 meters per second. It started moving at 30 meters per second. So that's our VI, and again, it should be positive, but that's okay. VF is positive 14 meters per second. That's its final velocity. And the amount of time that it took to go from 30 meters per second to 14 meters per second is 8 seconds. So we are trying to solve for the truck's acceleration. A. The formula for acceleration is delta V divided by T, or we can say A is equal to VF minus VI divided by T. We will substitute in the numbers that we have. The final velocity is 14 meters per second. Very, very important that you put this first. The initial velocity is 30 meters per second. Super important that you put that second. And then the time, substitute 8 seconds. And now we do the math. So 14 minus 30, if you do that in your calculator or just do it in your head, that's negative 16. We're subtracting a bigger number from a smaller number, so we're going to wind up with a negative. And then negative 16 divided by 8 is going to be negative 2. We get a negative answer here, which is exactly what we would expect because the pickup truck is slowing down. So whenever an object is slowing down, if its velocity is positive, then the acceleration should be negative. So yes, this answer does make sense, and the negative sign is good because it means that the pickup truck is slowing down, and we get the correct unit, meters per second divided by seconds, or meters per second squared. So that's going to be the end of our lesson for today. As usual, please check in with Google Classroom. I should have an assignment up there that should take you no more than 10 to 15 minutes to complete. Please make sure you submit that assignment. And I will see you tomorrow when we will be going over lesson 7.4, which is all about graphing motion. So we'll review graphing skills, and we'll see how graphs can be used to measure and record an object's movement. Until then, stay safe, take care, keep washing your hands. Have a good day. Talk to you tomorrow. Bye.